Welcome to the last lesson of Module 15, Causation and Correlation. Today we're going to determine if the relationship between two events is representative of causation or correlation. So what is causation? Causation is one event makes another event occur. Causation means that one event is 100% certain to cause something else. An example of that would be aerobic exercising. If you exercise, you're going to burn calories every single time. Okay. Correlation, on the other hand, indicates a mutual relationship between two or more things. So it's something, there is connection, but it doesn't necessarily imply causation. So one event does not necessarily cause another event. It might be connected, but it doesn't cause. Okay, so some examples here of correlation and how you can see them on a graph. The first one's a strong positive correlation. What makes it strong is that the dots are really close to the line there. What makes it positive is that the line is going uphill. As one event goes up, the other event goes up. The next example is a weak positive correlation. The dots are not close to the line. However, as one event goes up, the other event goes up, which makes it a positive correlation. So together, it's a weak positive correlation. This first example here is a strong negative correlation. Again, they're close to each other. The dots are close to the line. As one event goes up, the other event goes down. A weak negative correlation would be, like you see here, the dots are not close to the line, but as one event goes up, the other event goes down. It's a moderate negative correlation. And this is one that there looks like there's no trend here. This would be no correlation. So what do you think here? Some might say it's a weak positive correlation. It does look like as one goes up, the other one goes up as well, a little bit, but I would probably say this one's more of a no correlation. This one would be a moderate to maybe even a strong positive correlation. As one goes up, the other goes up. Okay. Just because two events are correlated does not mean that one causes the other. Okay. I've said that a few times. I want to make sure you understand that. Here's an example of that. If there are more firefighters at a fire, there's typically more damage done to the building. There is a correlation there. The more firefighters there are, the more damage typically done to the building. Does that mean there's causation? Well, no. Do the firefighters cause the damage? No, they're putting out the fire. The fire causes the damage. So what's the connection here? What's going on? Well, there's more firefighters because the fire's bigger. Makes sense. There's more damage done because the fire's bigger. Again, makes sense. The underlying cause is the bigger fire. The firefighters don't cause the damage. Okay, so I'm going to take you to a YouTube video here. I'm going to play about a minute of it. I'm going to show you an example of this. It's kind of funny a little bit, but I think it illustrates the point I just tried to make.
Bring
Get to the ad here first.
Moving season with Pods. Save up to 25% now on moving and storage. And
welcome. I came here today to warn you about the dangers of ice cream. You may not be aware of this, but these innocent-looking cones full of sweetness are one of the major causes of drownings. And I've got the numbers to prove it. So if you plot a graph of the number of ice creams that are sold, and you compare it with the number of drownings, you can see there is clearly an upwards trend. And I think it's very safe to conclude from this that we should ban ice cream because it's very dangerous. Since you're all smart people, you've probably figured out there's something wrong with my example. What's really happening here is, of course, that there is an underlying factor, which is nice weather, you might have guessed it. And if the weather is nice, more people will go out swimming and unfortunately drown. And at the same time, more people will buy ice cream. And it's not the ice cream that's causing the drownings. And here it's really easy to see that there is something wrong, but jumping to an incorrect conclusion about causality when you see a correlation is the most often made logical mistake. And today my goal is to make sure that in the future you can recognize this mistake, and I really hope you can avoid making it in the future for yourselves.
All right, so I'm going to go ahead and stop it there. Hopefully you gathered what's going on here. Okay. The ice cream did not cause the drownings. The underlying factor, like the firefighter one, was that the nice weather With nice weather, more swimming. More swimming means more drownings. Nice weather also means more ice cream. They're correlated, doesn't mean they cause each other. Okay. That video keeps going on with more to show you more of those things. So if you want to look at it more, copy that link and see more. Okay. So if you take away the cause, does the effect still occur? Okay. If it does, it's not causation. Okay. Determine if this is causation or correlation. I slapped a mosquito and the mosquito is dead. That's causation. Slapping a mosquito caused it to die. That's causation. The relationship between smoking and lung cancer, a little bit trickier. Is there a correlation? Sure there is. Does smoking lead to lung cancer? No. Smoking could. Smoking increases your chances of, doesn't cause lung cancer. Can other people get lung cancer that don't smoke? Yes. So smoking is not what causes the lung cancer. Okay. It's correlation. There's a strong correlation, but there's a correlation. Okay. So hopefully I made that point there with this lesson. That concludes this week's lesson. And we're going to get ready for the test next.